All right. Well, thank you everyone for joining today. Welcome to Applied Day 2020. As you can see up on the screen here, we've got a few more presentations. One more today as after this one, and then a couple more tomorrow. Let's see. So that's today and tomorrow. Here at Applied, the We Fit mentality, technology, training, implementation, support, services. We offer design and manufacturing engineering, software development, and reprographics. And this is moving to a containerized environment. I'm Justin Kalvoda. I'm a application developer here at Applied Engineering. And so here's kind of just a quick outline of our presentation today. So we're going to go through what is a container, different container managers, creating and managing containers within Docker, using containers for development, using containers for deployments, and then Docker deeper dive if we have time at the end. So first off, what is a container? A container is a standard unit of software that packages up code and all its dependencies so that application runs quickly and reliably from one computing environment to another. Basically, the app runs within its own protected environment. It has its own resources, and then it runs on the same kernel as the main operating system. This basically allows for broad use of the kernel rather than having to have a separate VM, virtual machine to run and everything like that and taking up more resources. This basically is kind of isolated on itself while still accessing all those same resources of the lower lying system. So what is a container? The difference between this of a container and a virtual machine is when you have a containerized application, you have the infrastructure underlying, you then have the host operating system running on top of the infrastructure, and then the Docker application running there. I'm using Docker as an example here as the management system. And then Docker itself then manages and runs all the containers underneath of it and handles all the communication in between all the items. And then whereas a virtual machine, basically you have multiple operating systems running on the one hypervisor with infrastructure underlying on that. So it's not instead of using the same kernel, it's now has to use separate kernels for everything. So first, we'll start off with container managers. Container managers are used to start, stop, create, destroy your containers along with monitoring and your running containers. They also manage all the images that you use to build and create your containers and how you manage them and everything. So these are just a couple of them. Docker is probably the most widely known. It was started in 2013. It runs now on all major operating systems. You can do both Linux and Windows containers. There's an enterprise and a community level. So the community level version is free. It's got pretty much everything you need. But then there is an enterprise available as well. And then we will be using Docker for this presentation. Any demonstrations or anything that I have will be through that. Containerd is another one, which I believe Docker is somewhat based off of. We also have Amazon Elastic or Microsoft Azure also all run those kind of basic container management systems. Next, creating and managing containers with Docker. So with Docker, there's pretty much some basic primary commands. You have pull, which is used to pull an image from a repository. You have run, which creates the new container based on an image. You have inspect, which is used to take a look at the specifics of your container or basically anything within Docker as it is. And then you also have the start and stop commands, and then the logs. So we'll just kind of take a quick demo here. And so here we'll basically see, increase the size here a little bit. I'm going to use basic Nginx image. We have, let's see here. I'll show you here. This is the Docker repository, Docker Hub. So Nginx, and this is where you can pretty much find anything that you want that they have available and running. This is an official Docker image. So basically, I'm gonna Docker pull that image first. So it's gonna grab the latest version tag since I didn't specify anything. Now it's gonna download it. So it's pulling all this information from the Docker services. Okay, and now to run it, Docker, we'll use the run command and -- name, just one. And I'm gonna add a port on here just so I can show a port mapping. So let's go 8055, because I know Nginx runs on port 80. So we just put port 80 and then Nginx, the name of the thing. So there, we didn't get any errors, so that is up and running. So now I should be able to go to my local host and you'll be able to see. Since I mapped that to the host. So, yep, and there we've already got a web server all set up and everything and no other configuration needed. So I will stop that and so you can see it running here and how long it's been up and the name over here. So you can see it's been up for 32 seconds. And another thing, I have several others running there. And now we can do something like inspect. Inspect the image. So now you can see all the stuff that went into the configuration for it. So this is kind of what basically resides in the background of it. You can see, what networks it's connected to, all the different pathing in the inside and everything. So I will take it down. There it's stopping, and then I'll just remove it because it's always good to clean them up because something like the port and everything will remain locked until it gets removed. Okay, so and that just a very basic launch a container, your first container and everything, and it just deploys that. So I'll go back. So next we'll do using containers for deployment. Here at Applied, we work on several different projects at once, and at any time you might have to help out another developer, or another developer will have to hand something off to you. And part of the problem with development is you can spend a lot of time setting up your environment and everything for your applications and stuff like that to run, whether it's you have to install a database, you have to install Redis or any supporting services, anything like that. So Docker allows a way to encapsulate that all basically into one configuration file that you can deploy and you can get off to running start right away. So using containers for development, create your own custom images to run new or existing applications. So basically, if you can create a new application, you can do that. If you have an old application that, hey, I want to update this or just get it so it's easier to hand off to another developer, you can now change that over to and Dockerize it, if you will, and allow you to do that. Everything is defined within the Docker file for the Docker image. It's built by the Docker by a Docker engine, and the Docker file is a description of changes to the base image needed for the construction of the new image. It's essentially a collection of layers built upon one another to create the final image. So you basically list out all the changes that you want from a base image, say base Linux or Linux image, and then add in all the changes, whether you want to import things or transfer code over or install something like Nginx onto it. You can do that. And then once it's done at the once, it's ready to go every single time. And then it just needs to be spun up into a container after that. So this is kind of a simple Docker file example. Something like this was actually created with Microsoft Visual Studio. They're adopting Docker quite a lot. And so they have this that gets auto-generated if you choose so. But basically up here, so line 3, you can see it's telling you from what image that you want to pull. And then you're changing the work directory to the /app, and then you're exposing the port of the container. That's not the host system, that's the container. And then you're also exposing 443 for SSL. After that, Microsoft likes to do a build on a separate image. So they're creating another image from the build. Then they're copying the source down and running the restore as well as the build commands on there to build it within that image. You then move on to the building it and then moving it over to your actual image at the end here, and then specifying on line 22 there that you want the entry point to be the .NET runtime, and then you're passing in the Docker demo web.dll. So it knows what to run and everything like that and start up. And basically the rule of thumb for any image and subsequent container is that you should only run one process per container. So if you want to run your desktop or database on one, you want to run your web page on another, and you basically build them as services, so a microservice. So I will do a quick demo here of a simple Docker file that I wrote. So here's the Docker file. So again, all I'm doing here is I'm simply pulling in the Nginx, basing it on the image of the Nginx, simply setting the work dir to the default area within the Nginx where the files are hosted, and then I'm copying over this index.html file on there. So I'm running my custom code within there. So I'll toss this up here. So you can see a Docker file there. So you just do a Docker build, Docker file. Oh, there. So there you can see the different levels that it's building. So it takes the Nginx image, because that's the first step, and creates a layer based on that. Then it creates another layer based on that working directory and copies, and then it'll remove any containers that aren't necessary and takes them out. And then now it has copied over this index.html file into there. And now you can see now that it's successfully built it. So we should be able to run this. And since I don't have it named specifically, I just use the Docker image ID that it generated for it. Oh, okay. Let's see here. So now if I go to, oops. So you can see I entered in, and now I've got my own custom index.html there that I had copied in. So, and then another option you can do is I can mount it into there. So -v, which would allow me then, oops, to run, let's see if I can find that. Oh, this is the port collisions and the name collisions. So we'll do tech file example2. So you can see I created another container there. And that's under 8024. And you can see it's that same file, except now I can go into there and edit it locally on the file. And the changes will automatically populate through. And those would change, then you could sit and refresh and it would pass all those in. So I'll Docker remove, or container remove. I'll actually clean these up quick. And since they're still running, I have to add a -f flag on there to force it. So there, those two are removed. So that kind of gives a basic layout there. And then go back to presentation. So, so applications commonly have multiple parts, as you know. They have like a web page, an API, database, unit tests that need to run, supporting services such as Redis or RabbitMQ or anything like that, as well as the architecture, whether on production that the web page is going to be on the DMZ of the network and the database is protected behind a firewall and stuff. So these are all things that you can mimic on your machine. You can create multiple services to handle all the different items, as well as you can create multiple networks and have each specific service be a part of one or multiple networks. So you can effectively isolate and test for those items. Oops. So a simple web app that I'll kind of go as an example here. We have a web page, an API, and a database. And then we want two networks. We want network one, which is going to be part of the DMZ, and it's going to have the web API or the web page and the API are both going to be accessible from there. And then network two is going to have the database, which is going to be behind the network or behind the firewall. And you'll have the API as well. So the API will be shared, will have access to both networks. So I'll jump on a demo of that one. So let's take a look at the here. So this is using basically Docker Compose. So this is where you can define out all your different services along with any networks that you need, any volumes that you need, or anything like that. And this is kind of where it really comes in handy for the development aspect of things. So under here, you have to have define the version of the file. If you don't, it's going to go default to a specific version. Services, so services is anything that's going to launch an image off of launch a container based off of an image. So here I have the web page based off or service defined. I'm telling it to use image, this Docker registry, and then Docker demo web. and I'm telling it to build it. So it needs to go in, find that Docker file and build that, as well as exposed ports. So this is the same as the -P on the command line. And I'm also telling it the networks. So I want it to be part of the front end network. And at the bottom here, you can see I have defined the different networks. So I want a front end, back end. Since I don't define anything more than that, when Docker Compose builds this, it's going to assume that those have not been created, or it'll check to see if they're created. If they're not, it'll create it for it. And then I have the API defined here. Same thing with the build context and defining the image as well as the ports. This is obviously a different port than that one. And then networks, I want it to be part of the front end as well as the back end. And then the Docker demo DB, I'm telling it to use, I'm having it build this image on its own. We can also build this, we can have it just use the base Postgres image, which it works just fine. I have just added it on in the Docker file. I want the ability to have the ping command in there. So one of the things you can have it do within the Docker file is install different software suites, basically anything that you want. You can have it install on there. And you can see I have it as well installed on the other two images. They're just super simple images, but basically I'm just defining that to show that. So let's see, so defining that. So it's just building that, and all what it's doing is just running that command. And then an environmental variable is this one, it just happens to be required for the Postgres image. And basically I'm just telling it to that there's no security necessary to trust whoever wants to connect, since it's just a demo. And then networks, I'm telling it to just go onto the backend network. So we'll go to there. So I'll start that up. And for this, you want to do Docker Compose. Oops. And that's the composer. And we'll just build it first. So it'll go through all those different services and build. Oh. So it's going to look through all those different services, and you can see it's doing kind of that same thing where it builds that. Now you can see if you've ever installed anything on Linux command line, you can see it running the updates and installing that application, as well as that one. So there, now all those images have been built. So all what I need to do is Docker Compose up. And now it goes through, it saw that those networks needed to be created. So it created those. And then as well as the three containers. And then this is just the logs because I didn't suppress that. So now we can start to log in to those specific ones so I can show the different, or the delineation between the networks. So I'm running Docker execute. So this is telling it to run something on that specific container. So we'll go grab that database. And I'm telling it to run bash. Oh. And bash. So now I'm within that container. I'm within the context of that specific container. So anything that is on there, I have access to now. So I can run. So we installed that ping command. So now you can see that it has been installed. So I'm going to do this for the other two and get those into there. The -IT means interactive terminal. So it means that I want it to return something to me like that. And then just the image name and bash. And the last one. There. So now this top one here is the API. So I should be able to ping either or of those. So I'll do Docker demo DB, and you can see we're getting a response from there. And then now I can also ping Docker demo web. And you can see I get a response to there. So we got a connection to both of those. And Docker itself has a built-in DNS resolver. So you can use just the names of the containers and be able to talk to, use those as definitions to talk to the other ones rather than having specific IPs. So this one I should be able to, so this is the database, so I should only be able to connect to the API. So we'll try connecting to the web, and you can see no address associated, but I should be able to ping demo API. You can see I cannot talk to the API on that one. And this one, the same thing. I shouldn't be able to talk to the database. No address associated, but I should be able to talk to the API. So we've got that dual network security there that we can isolate and keep everything kind of separate. And then, so I'll stop that. And then you can see it kicked us out of there because when you end Docker Compose like that, it exits out completely. It has not removed everything yet, so you have to do a Docker Compose down to pull everything down. And what that's going to do is it's going to go through, delete all the networks, delete all those things that it created so that it cleans that up. Let's see. And then I was going to go back up to here where you can see the different builds. So it's smart enough to know that when you've built something before or it's the exact same, you can see here the different ones that it's using the cache. And basically what that's saying is, hey, I've already built something that's identical to this. I'm not going to rebuild it, so I'm just going to reuse it. And that's another beauty of Docker, is especially on Docker Hub, because you can build these images and you can push them up to Docker Hub, so anyone can use it, or you can pay and have it privately stored so it's just accessible by you or your company or anything like that. So when you do that, it'll take that, it'll use those same ones rather than rebuilding, reinventing the wheel. It'll go out and grab those exact same ones and rebuild and build your final image. And even if the images happen to be the exact same, it'll actually just return that same image back if you happen to build something identical to someone else. There's that, and then I had cleaned up. So that's kind of a basic demo app. It really didn't do anything. It was just more or less Docker files, but it kind of just showed how things can be deployed relatively quickly, and anything like that. So let's go back to presentation. So using containers for deployments. So this is where you get into the production level, something that you're gonna need more than just Docker Compose. You'll actually want an actual container orchestrator is what you really want. But using containers for deployments, it's an easy way to scale. It's easy management, and you will need an orchestrator though to make it easy. If you don't, it would get very complicated to try and keep anything running with either just Docker Compose or Docker itself. It's easy, especially or with certain orchestrators, the rolling updates are really quite beneficial if you have a lot of services running. It'll sit there and you can do one at a time, four at a time. It can basically roll through those and make sure that things come up before it moves on. Same thing with rollbacks. If something happens that you notice, oh, stopped working, you can roll those back fairly easily and it'll just back up to that previous image. Configuration management is also quite easy with this because you can basically define it once and roll that out. And the theory behind microservices is that you remove as much dependencies as you possibly can, and by taking that out of there. So for the orchestrators are software suites that manages a lot of the common container actions. It wraps those commands into one management system, and then they basically handle deployments, restarts, balancing. If a service fails, it makes sure that another one starts up, or if you have a server that goes down, because with orchestrators, you typically can have them deployed across the world if you want, and have them all within the same network or anything like that. So you can drop, and so if a server drops off, it can kick up a new one and start up another one if it needs to. So I'll just kind of do a quick demo. One of the orchestrator that I primarily use is Docker Swarm. It provides most all functions that you need for most places. Higher level businesses and stuff like that are likely going to need more, but then they can go to a different option there. So I will pull up one of mine here, and this will just kind of show what this is. So this is a Docker Swarm that I have running on my local system at home. So Docker services ls, list them out. So you can see I have 3 different services running right now. I have Portainer, which it runs just one replica, and then this Portainer agent, which runs on every single node that's connected. And so right now it's running 11 of 11, as well as this Viz, which I'm currently running on 4 different nodes. So we can take a look at node ls. These are the different nodes or servers that I currently have connected to. So there's a good decent amount of them, and most of these are VMs. Some of them are just regular servers. And so this allows, so Docker service. Yeah. Viz I want to run. There we go. So you can see the different services. So it has 4 replicants. So you have the 1, 2, 3, and 4, which you can see that it's had some other ones shut down. So you can see which node they're running on, so which server. And I'll run this here. So Docker. So we'll just watch this for every second. Docker. This PS. So this will refresh here, and then I can basically go down and shut down the one that's that Agatha King, and you'll be able to see it kind of in real time there, drop off, and then it'll kick on and automatically switch over to another one. There we go. So now you can see it shut down that one, and now it has this running on Acaria Planum, and it's running up, and that it started in good health. So that kind of gives a good definition. And this is Docker Swarm. This one is, like I said, fairly lightweight, fairly easy to understand. Another one is Kubernetes, which I'm also getting used to, but haven't had a whole lot of experience with it. But that one has pretty much anything that you could possibly need to run things, any management or anything. But they often say if you need Kubernetes, you need at least a full-time IT staff just to run Kubernetes because it just gets so complicated with other things. And so it's nothing that I've really delved into yet, but this kind of just gives the thing. And Docker Swarm itself works really well. You can run it across different places and everything like that. So looks like we do have some time for Docker, a little bit deeper dive into Docker, the different commands and stuff like that. I'll kind of take a look. And so some of the common run options that you run into, bind and volume mounting. So when you create a container, it has no access to your file system or anything like that. That's another protection feature. It keeps everything isolated. By bind mounting, you can say, I want to connect, this specific directory on the host machine to a specific mounting point within the container. You can also do networks, kind of like what I did with the Docker Compose file that was prior. That one was able to do that, create those two different networks. You can also create those all manually by hand as well. Port mapping as well is a really big one that you need. And then detaching as well. Inspect is a very important one. Logs, network creation, and volume creation. So rather than just connecting to or mounting to a specific place in your host system, you can also create a volume, which is basically a virtualized area that basically allows you to save any changes or anything like that. When you run a container, if you don't do any type of volume creation or anything like that, any data or anything that has gotten saved or anything like that will have gotten wiped out at the end. It gets deleted because it's isolated to that specific container. But if you create volumes, you can then connect via those. So I'll just kind of jump out and do a demo quick. So let's create a volume. So Docker volume create. So I'm just going to create a new volume called test volume. So test volume is now isolated out there, so I can now refer to that. So Docker run mount the volume. So we want test volume and connect that to /test/mount. And I'll just run Nginx. So that should have started up. So now I should be able to log into that one. You can see that one's running up there. And if you don't put a name in, Docker just creates a random one for you. So now I should be able to go /test/mount. And so here's where that directory is now. So I can access that on there and allow it to save there. So I can delete this now. So remove or touch or add a file. And then exit. And we'll just remove it. And then now I should be able to run this again. Let's run this -d instead. And now I should be able to connect it, and that file should still be there. So you can see that test.txt is still in existence. So that allows you to save stuff between items there. And the docker inspect command basically works with any of those. So we'll exit out of there. So docker inspect, we can inspect that. Docker volume. So you can see I just jumped into the data here. You can see where it was created, where the with driver it used, basically anything that it used to create that. And so for volumes, it's usually not a whole lot. It's more important with like Docker network. Network create, test network. And so now you can Docker inspect. So this one comes in handy, especially if you're trying to figure out something specifically why something's not working. You can see exactly all the configurations and everything that went in to create it. Again, for like drivers and stuff, you can also define these too, but typically they're always the specific, it usually defaults to this bridge network. And then you can also take a look at all your images. So I've got a lot of them from a while ago. But you can see all the images we just created 18 minutes ago, the Docker demo DB. Let's see if that one's still running. You can jump into the logs for these. At any time. And that one just apparently doesn't have any specific logs. Let's see what else I had on that list. So another one that I had shown here is -d. -d tells it to detach, so don't sit there waiting for output or the log file from there. So that kind of waits for that. Volume mounting, that's probably a good overview at least of the beginnings of Docker. Again, you can go super deep dive into these things. I had one example I had was we had our team site for our company here that's written fairly old, long time ago in PHP. And it was just a nightmare to get up and running on someone's local system. So it usually just a developer, if they had to make any changes, it was typically you just worked right on the server and everything, a test server. And so that was kind of a pain. So I decided, I had some free time. I'm gonna Dockerize that. So I spent some time, and when going through that, it does take some time because you got to basically duplicate what's on that server as far as libraries, anything like that you need, and you have to get those installed. So it took quite a long time to get all those installed, working with different versions of the applications and stuff like that. But once it was up and running, it's now been compressed down into, you just run one command at the beginning and it'll do all the installs. It will create your databases. It will import any data that it needs or anything like that. So it gets it up and running, and you save just a ton of time when it comes to development. And it's because containers and images are so static that you're pretty much guaranteed to be able to run it no matter where, and just sit there, run a Docker Compose up, and bam, it's good to go. So with that, some other resources, the hub.docker.com is a huge resource. There are so many commands, so many sub commands and everything within Docker that you can always most likely find anything, and they're all pretty much defined on there. And then there's a Docker captain named Brett Fisher. He has a YouTube series and everything like that. He's very passionate about Docker. He runs a weekly show and everything where he talks about different issues with Docker and Kubernetes or any of those things. So he goes pretty in depth into any of those. So with that, so I highly recommend checking him out if you're interested in learning more and getting deeper into it. So I just wanted to say thank you, and I don't know if there are any questions or anything like that.
Justin, what can Applied do if someone's experiencing any sort of software development challenges, or if they need help with their containers? What kind of services does Applied offer?
Right now, I mean, we pretty much kind of, we're not advertising it yet, but I know at least several of our developers are pretty well versed in it. So, it's get in contact with someone from here, and, they'll forward it on to us. And we're more than willing to take a look at anything. All right, with that, I guess, thank you for joining. Hopefully you found this interesting, and, maybe dive a little deeper into it or anything like that to take a look at it. You can contact us, our webpage there, email address, and then the upcoming events that we have coming up for in May and June here, all online. And then
that's all included in a handout as well, all of our upcoming webinars through the end of August.
Okay. And then, yep, these are the rest of the Applied days. So join in, and thank you.